Okay, I'm going to go over a little worksheet that you're doing at the very start of the unit. Doesn't require you to watch any videos, but I think it might help if I kind of walk you through this a little bit. So this unit is about confidence intervals. What are confidence intervals? It's just a range of values that estimate the value of a population parameter. So for instance, if we wanted to estimate the average heights of all males, a confidence interval would give us a range of values that we could be confident that that's the true height of all males. So what a confidence interval and how you report a confidence interval is, you say we are blank % confident that the true mean or proportion is between blank, and you would put two numbers. So what does that mean? It essentially means that if I were to take many samples over and over and over again, approximately that % of the intervals would contain the true mean. So if I took a bunch of samples of males, calculated an average and calculated a confidence interval, another sample of male, calculated a confidence interval, another sample of male, calculated a confidence interval, that percentage just means that % of all of your confidence intervals capture the true mean. So at this point, it's not super important that you understand that. The videos go a little bit more into that, but that's essentially what a confidence interval is. So the way that you calculate a confidence interval, the general form is it's basically an estimate plus or minus a margin of error. So in this case, an estimate could be X bar. The estimate can be P hat, depends on if the problem is involving a mean or proportion. And then we calculate this margin of error. So here's the formula for the confidence interval for means. It's X bar, that's our estimate, plus or minus something called the critical value times the standard deviation of your sampling distribution. So that notation should look familiar from the previous unit. Okay, and this is how we calculate it. This whole part after the plus minus is called the margin of error. Okay, and then for proportions, it's the same structure. It's your estimate plus or minus your critical value times the standard deviation. Again, that's the margin of error, and here's the formula for proportions. That should look familiar from the previous unit. So now the question is, what are critical values? This number right here. So for now, you don't really need to worry about that. We get a little more into it. Here are some critical values for some commonly used confidence intervals. Obviously, if you're trying to report something, you don't want to say you're 50% confident. That's not very confident. We generally choose confidence levels greater than 90 degrees. So here are some critical values that we use. We'll talk more about how to calculate that. You could read this, but you will learn how to calculate those and find them in your table. So the first example I go over is fully solved here, but I'll just talk you through it. Okay, so it says, suppose we want to estimate the average weight of adult males in this county in Georgia. We draw a random sample of 1,000 men and weigh them. The average man in our sample weighs 180 pounds with a standard deviation of 30 pounds. We're calculating a 95% confidence interval for the mean weight of all men in this county in Georgia. Okay, so step one, we're going to identify all the symbols. So for mean problems, we're going to identify the sample mean, standard deviation, your sample size, and your critical value. So in this problem, we have the sample mean, so that's 180. The reason I know that's a sample mean is it says our sample weighs, the average man in our sample weighs 180 pounds. And then our standard deviation, says right here, is 30 pounds. Our sample size, we say we take a sample of 100 men and we use the symbol N to represent sample size. And then our critical value, we're going to use 1.96 because we are calculating a 95% confidence interval, and 1.96 is the critical value that we use. So step two, we're going to calculate the margin of error. The way we calculate the margin of error is we take the critical value times the standard deviation. So plugging what we know in, the standard deviation is sigma over the square root of n, so it's going to be 30 over the square root of 1,000, so that's approximately 0.9487. So then to calculate the margin of errors, we're just going to multiply the critical value, 1.96, times the standard deviation that we calculated, 0.9487, and that gives us 1.859. So this right here is our margin of error. So to construct the confidence interval, we're basically going to take this number and we're going to add it and subtract it to our estimate. Our estimate is our sample mean. So it's going to be 180 minus 1.895. So this number came from 180 minus 1.895. And this number came from adding 180 plus 1.895. Lastly, we interpret in context. This is how you interpret confidence intervals. You state it like this: we are 95% confident that the true mean weight of males in this county in Georgia is between 178.14 pounds to 181.86 pounds. Make sure you put your units. All right, the next problem, I'm going to guide you through it, but you're going to fill in the important stuff. Okay, so this is a major metropolitan newspaper selected a sample of 1,600 readers. So that's the first thing that's important. That's our sample size. So that's 1,600 from their list of 100,000 subscribers. So that 100,000 is just the population size, but we don't need to identify that. They asked whether the paper should increase its local news. 40% of the sample, so that 40% describes the sample, which means it's a statistic, the sample proportion. So that's 0.40. Wanted more local news. What is the 99% confidence interval? So 99%, I'm going to go back to my table here. 99%, the Z star value is 2.576. Okay, so that's step one. Step two, we're going to calculate the margin of error. So it's going to be the critical value times the standard deviation. Well, we have our critical value here. So it's going to be 2.576 times, I'm going to calculate the standard deviation up here. So since we don't have P, because that's what we're trying to estimate when we're using our formula, instead of P, we're going to use P hat because we're using our best estimate. So that's 0.4 times 1 minus 0.4 over 1,600. So that you get approximately 0.012. So that's our standard deviation. So to calculate my margin of error, I'm going to do the critical value times the standard deviation. So 2.576 times 0.012, and we get 0.03. That's our margin of error. That's what we're going to add and subtract to our estimate. So to construct our confidence interval, it's P hat plus or minus our margin of error, 0.03. So we're going to do 0.4 minus 0.03. That's 0.37. And we're going to do 0.4 plus 0.03. That's 0.43. So our confidence interval is 0.37, 0.43. So to interpret in context, we start with our level of confidence. We are 99% confident that, and then we say the true proportion of readers who would like more coverage of local news is between 0.37 and 0.43. So make sure when you're doing proportions, these numbers for proportions should always be between 0 and 1. Remember, it doesn't make sense to have a proportion, a negative proportion doesn't make sense to have a proportion greater than 1 because that would be over 100%. All right, now we're going to do a couple more examples, but this one, I'm not giving you much information. You're just going to kind of follow the steps, or I'm not filling in anything for you. So this is a problem about means. It says a company that produces white bread is concerned that the amount of sodium in its bread. The company takes a simple random sample of 100 slices. So that means N is 100. And computes the sample mean to be 103 kilograms. So sample mean is X bar is 103. That's our estimate. And it says a standard deviation of 10 milligrams. And then we're constructing a 99% confidence interval. So the Z star value for 99% is the same one as the previous one. Yeah, 2.576. Okay, step 2, we're going to calculate the standard deviation. The way we do that is we do sigma over the square root of n. So that's going to be 10 over the square root of 100, which is 1. So that's our standard deviation. So our margin of error is our critical value, 2.576, times our standard deviation. So that's 2.576. And now to calculate or construct our confidence interval, it's going to be our estimate, so x bar, plus or minus our margin of error, 2.576. So we're going to subtract 2.576, and then we're going to add 2.576. So we get 100.42 is a lower bound, and then 105.58 is the upper bound. So then to write our confidence interval in context, we're going to say we are 99% confident that the true mean sodium level is between 100.42, and the units are milligrams, and 105.58 milligrams. All right, example number 2, this one's about proportions. So it says the mayor of a small city has suggested that the state locate a new prison there, arguing that the construction project and resulting jobs will be good for the local economy. A total of 183 residents show up for a public hearing. So your sample size is 183. And show of hands finds only 17% are in favor. So in your sample, p hat, 17% are in favor, so 0.17. Construct a 90% confidence interval. So the z-star value for 90%, I'm going to go back to my table. 90% is 1.645. All right, so now we need to calculate the margin of error. So we're going to calculate the standard deviation first. So that's going to be p hat times 1 minus p hat. Again, we're not using p because we're not given p in this problem. That's what we're trying to estimate, over n. So that's about 0.028. Then our margin of error is going to be z star, 1.645, times the standard deviation, which is about 0.05. So then to calculate my confidence interval, it's going to be my estimate, 0.17, plus or minus my margin of error, 0.05. So my lower bound is going to be 0.17 minus 0.05 and 0.17 plus 0.05. So my lower bound is 0.12 and my upper bound is 0.22. So then my answer in context, we're going to say we are 90% confident that the true proportion of residents who are in favor of the prison project is between 0.12 and 0.22.